Okay, welcome to the sixth in our series on 5 random GCSE questions. These are taken from calculator papers and some of them are quite tricky towards the end. First question, we've got 9 graphs and we've got 4 equations. We've got to identify the graphs that belong to those equations. Sine x repeats every 360 degrees. Okay, and the sine of 0 is 0. The only graph there that's sine x, it could be sine x, is this one here. This one over here is probably cosine x, but this one is sine x, and that's the one we want. Okay, the second one is a cubic. Now, the only cubic could be this one. It changes direction sort of twice. What's happening there is it's also going through the point 0, 0. And if you look at this, when x is 0, y would be 0 as well. So it has to be f. Okay, the third one is 2 to the power x. That's showing exponential growth. In other words, the gradient increases as x increases. Okay, and it goes on forever in both directions. And when x is 0, it will cross the y-axis at 1, because anything to the power 0 is 1. It's this one here, a. Okay, just a little note about that graph. It's not quite right because it looks like it's starting to curve away from the axis here, which of course it wouldn't do. It would continue to approach the x-axis but never reach it. And finally, this is a reciprocal graph. Okay, as x gets very big, y gets close to 0, and as x gets very small or close to 0, y gets towards infinity. It's this one here, because the same happens in the negative quadrant here. Okay, so it's graph H. Okay, the other ones could be, well, that could be y equals negative something over x. That one could be a quadratic like x squared minus 5. That one could be a negative x squared quadratic because it's upside down. Okay, and that's negative exponential growth or exponential decay. Okay, next question. This one requires us to use algebra to prove that is equal to 1 over 33. So what we need to do is call these numbers something. I'm going to call this x and I'm going to call this y. Okay, starting with x, I'm going to just say that x equals 0. Now I'm going to write 13636 like that. Okay, then I'm going to work out 10x simply by multiplying by 10, so moving the decimal point, 1.3636. Then I'm going to do 100x, okay, and that's going to give me 13.636. And then I'm going to do 1000x. Now you don't actually need to do all of those. I tend to do them all, just timesing by 10 each time. And what you're actually looking for is the first pair of numbers where the decimal part is identical. So this would be 136.36. Okay, so both of these two parts have a decimal bit that is the same. Okay, they both have 0.36. So what I'm going to do is subtract them from each other to give me 990x equals 135 exactly. Yes, if I take that, take away that, it'll give me 135. Now, you might not notice straight away, but both of those divide by 45 to give me 22x equals 3. Okay, so therefore x must be the fraction 3 over 22. Okay, exactly. Now for y, it's a lot easier. Y is 0.222, etc. Okay, and therefore 10y is 2.22. Because they both contain the same decimal part, subtract them, we get 9y is 2. So therefore y is the fraction 2 over 9, 2/9. Now I need to do the product of x and y. I'll do that over here. So x times y equals 3 over 22 times by 2 over 9, and that comes to exactly 1 over 33, which is what you had to show. Okay, which was up there. And that's it. Next question. Now this is an interesting one about a circle with radius 2. So the radius of that circle is 2, the square root of 4. Okay, I've done a sketch of it because you need to see what's going on here. Now P is the point 3 over 2 root 7 over 2, and it's on that circle. Okay, so we take their word for it. Now 3 over 2 is 1.5. 1.5 is here. So it's this point here that we're talking about. Okay. Now the radius of that circle goes from here to there to the point P. Okay. Now the tangent is the line that meets the radius at 90 degrees. That's one of the circle theorems. So roughly speaking, if I can try and get this about right, the tangent would be a straight line that would go something like this. Okay? And it would cross or touch the circle there. That's about right. And it would meet that blue line at 90 degrees, you see. So we need the equation of that tangent. Okay, let me just try and settle that down somewhere. There it is. Okay, so what we're going to do is find the gradient of the tangent by first finding the gradient of the radius. So the gradient of the radius is actually easy to find. The gradient of r, I'll call it r for radius, and that's simply, well, because it's going through the point 0, 0, it's just this divided by this, the y height divided by the x distance. In other words, I'm working with this triangle here. I'll just show you what I'm doing. So basically I'm looking at this triangle here and I'm doing the rise divided by the run, okay, which is that bit there. And I'm just saying, well, that's root 7 over 2, that's 3 over 2. If you divide them, the 2's cancel and you get that the gradient of r is root 7 over 3. Okay, let's put that back in green. Root 7 over 3. Okay. Now, if that's the gradient of r, then the gradient of let's call this tangent t. So the gradient of t is the negative reciprocal, you see. So it's negative 3 over root 7. Now, it does say find an equation, all right? It doesn't ask you to say it in a particular form. And there's several ways you could do this, because at that point, if you can remember this, y minus y1 equals mx minus x1, then you can answer the question straight away. Okay, so y minus y1 equals mx minus x1. That's the equation of a straight line with a gradient m that goes through the point with coordinates x1, y1. So I could simply write the answer as equation of t is such that y minus root 7 over 2, because that's a known point on the line here, you see, with a y coordinate of root 7 over 2, equals the gradient, which is negative 3 over root 7, okay, brackets x minus the known x coordinate, which is 3 over 2. Okay, now that's got to get you the marks because it's an equation of the line t. Now you could do lots of simplifying, you could use your knowledge of surds and tidy it up, but it really doesn't require that. It just says an equation. Okay, and what they'll be looking for is your understanding of radius meeting tangent at 90 degrees, the use of the negative reciprocal, and that's it. Okay, so that's how I would answer that question there. And next one. Solve algebraically these simultaneous equations. So this is a classic situation where you've got one quadratic and one linear. Okay, it's an unusual quadratic. It's a special type of quadratic in two parts, but that doesn't matter. You just need to use the algebra. So what you need to do is first of all rearrange the linear part. Okay, so I would say that implies that x equals 1 minus 2y. Okay, and then I'm going to replace the x in the first one, okay, with 1 minus 2y. I'm going to call this equation 1, okay, at the top, and I'm going to call this one equation 2. Okay, so I'm going to sub equation 2 into equation 1. Okay, I could have done it the other way around. I could have written y equals a function of x and replaced the y with that. The only problem with that is it would have left me with a fraction over 2, you see. So that's why I've done it this way around. Okay, so let me do that. So in basically this becomes, instead of 2x squared, it becomes 2 lots of 1 minus 2y squared, okay, minus y squared equals 17. Expand out the brackets, leave the 2 there for the moment. That becomes 1 squared minus 4y plus 4y squared. Okay, if you square that bracket, minus y squared equals 17. Now, tidy this up or multiply it out. 2 minus 8y plus 8y squared minus y squared minus 17 equals 0, because this is going to be a quadratic in y, you see. Well, that gives me 7y squared. Okay, 7y squared. It gives me 8 minus 8y, and it also gives me minus 15, okay, and equaling 0. Now it looks quite difficult to factorize, and it may be that you need the quadratic formula, but having said that, if it does factorize, it's going to begin with 7y and y, okay, because they're the only factors of 7 being a prime number, you see. And in fact, it doesn't take long to see that the factorization does work as minus 15 there and plus 1 there. Okay, so that gives me two possible values of y. So from the first bracket, y equals, now it's going to be 15 over 7, okay, like 2 1/7, or y equals minus 1. So they're the two y values, but of course for each y value there's a unique x value. So what you do is you sub those values into the linear equation at the top. Sub y values into equation 2. Don't try and sub them into the quadratic because that just complicates things and you've got to be taking square roots. So you always sub them into the linear one. So when y is 15 over 7, x equals 1 minus 30 over 7, okay, which is equal to, well, it's 7 over 7 minus 30 over 7, which is going to be minus 23 over 7. Okay, and when x equals minus 1, well, let's just do it how I did there. The other value of x is just simply x equals 1 minus 2 lots of minus 1, which is 1 plus 2, which is equal to 3. Okay, so we normally just present the solutions nicely. So I say that x equals 3, y equals minus 1. They come as a pair, you see. Or x equals negative 23 over 7 when y equals 15 over 7. Okay, and that's my solution set there, okay, in that little box, which is always a nice way to present the answer. Otherwise, they're all sort of mixed up in the working. Okay, so next question. Now, this is a good one because it contains bearings as well as the sine and cosine rule. Okay, so you've got to work out the bearing of Chorlton from Acton. So what I'm going to do first is mark on there what you're actually looking for. So you're looking for the bearing of Chorlton from Acton. Okay, and that is actually all of this angle here. Okay, because it's measured clockwise from north. Okay, so it's 37 plus whatever this bit is. Now I'm going to call this little bit in here theta, to give it a name, okay, an unknown angle. And I'm going to call this length across here d for distance. Now, the reason I'm doing that is because I'll show you how we can work this out. So I'm going to put some extra numbers in here. These two are parallel lines, 37 and 143, because those angles are what we call co-interior. Okay, so that's 143 round there. That means I can work this out. That's 67, okay, because it comes from 360 minus, I'll put some working down because it says you must show all your working, 160 minus 150 minus 143, okay, which is 67. Remember, you've got a calculator. And then I'm going to say, well, okay, I've got two sides and an angle. Now, you might say, well, I can use the sine rule because I've got two sides and one angle and I need another angle. But the problem is you don't know the side opposite this angle, and you don't know any of these angles either. So I'm going to have to use the cosine rule first to find the length d. Then I can apply the sine rule to find this angle theta. That's the only way I can do this. So what I'm going to do is I'm going to use the cosine rule. I'm going to say d squared, okay, equals 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of 67. Okay, and if I rearrange that, I get that D equals, so you can do this on the calculator, of course. So I'm going to square root that once I've worked that out on the calculator, and it comes to 9.41 9.41991. Okay, so you can get that quite accurately. You could work with 9.42 easily within this question. Okay, because your final answer's got to be given to one decimal place. So using that value of D, I can now apply the sine rule. All right, so D equals, I'm going to put D is approximately equal to 9.42. Okay, so I can say that D, so what I'll need to do is put sine 67 over 9.4199. I'll use that. Okay, equals equals sine theta over 9. Okay, because the side opposite theta is 9. So that's applying the sine rule. And therefore I just need to multiply both sides by 9. Okay, so the next job is just to take that, just make a copy of that and show you what, because I'm showing all my working because it asks me to do that. I'm just saving a bit of time, so I can just rewrite it again. Just take the 9 out the way. Okay, and put it in front of this, so I'm timesing that by 9. Okay, and that gives me the value of sine theta, and that comes to, so what does that come to? Well, it doesn't matter, whatever an answer I get, I can just say that theta equals the inverse sine of that, and that comes to 61.578. 61.578. So all I've done is just put the inverse sine of that on the calculator. Okay, with some more decimal places after that. Okay, so that's what theta is. So the bearing, the required bearing, given answer correct one decimal place, is simply going to be, so bearing of C from A, or the bearing of A to C, but we usually say C from A, is going to be 37 plus theta plus 61.578. Okay, but you only need to do it to one decimal place, so that comes to 98.6. 98.6. Now just one more thing you have to do, okay, is you have to put a 0 in front of it. For a bearing it has to be 3 digits. Okay, so watch out for that one. 3 digits before the decimal point. Okay, and just say that that's to 1 dp. And if you look at the diagram, it may not be drawn to scale, but it does look as if it could be correct, because it looks a bit more than 90 degrees, doesn't it? Okay, and that's the end of that question and that video. Hope that was helpful. Take care.